Hello everyone, in this video I will show you some examples of the four cases. So we have learned in chapter 9 there are four cases. Case 1, large independent sample mean problem. Case 2, small independent sample mean problem. Case 3, large independent proportion problem. And case 4, paired difference cases. So let's see the example 1. So if you wish to examine that whether it will make a difference of obese people on a low-fat diet compared to a regular diet, and there are two samples of 100 for each group, and the standard deviation and mean is in this question is given. Now let's see. First, you need to highlight what's the question about to frame the non-hypothesis and alternative hypothesis. And there is a keyword, make a difference. So it will be not equal case. And usually we consider the first dimension as 1. So we consider low-fat diet as 1, and the second mentioned as 2. So regular diet we consider as 2. So in HA, which is the claim, mu1 not equal to mu2, they will be different. So we write one more step as mu1 minus mu2. So in HA, mu1 minus mu2 not equal to 0. And let's see the samples. So we have 100 sample of the group 1 and 100 data for the group 2. Although the sample size are the same, 100 for group 1 and group 2, but they are not case 4. They are not paired difference problem because they are independent. So the people on a low-fat diet, they are independent with the people on a regular diet. They will not influence each other. So this will be case 1 problem. And follow the test statistic formula. It will be a z-score for the test statistic. And D0 is the hypothesis value. So in H0, HA, 0 is the hypothesis value. So D0 is 0. And after calculating the result, the test statistic is 3.09. And we will use the two methods to make a decision. So the first one, we need to find out the critical values for the rejection region. And because it is not equal case, so it will be two-tailed problems. And alpha is given 0.05. So the critical value is negative 1.96 and 1.96. So that is the rejection region. And next, we need to see the test statistic in the rejection region or not. The test statistic is 3.09, so it is in the rejection region. Our decision is reject H0. So this is method 1. And the second method, we can use the p-value to make a decision. So let's see the picture first. The p-value starting point is the test statistic. And because this is two tails problem, so we need to highlight the two sides for the p-value. And we need to use the z-table to find out the table value according to a z-score, 3.09. So the according table value is 0.4990. And remember, this is two tails problem, and the p-value is two sides. So you need to time 2 at the end. And the result is 0.002. And after that, we compare to alpha. Alpha is smaller. The 0.002 p-value is smaller than alpha, which is 0.05 is given alpha. So the result for the decision is reject H0 because p-value smaller than alpha. And lastly, it's better to interpret the result. If we reject H0, there is sufficient evidence to indicate the claim in HA. So there is sufficient evidence to indicate that it will make a difference of the obese people on a low-fat diet compared to a regular diet. Now let's see the example 2. So it will be the same testing. We want to figure out whether it will make a difference of obese people on a low-fat diet compared to a regular diet. However, we don't have a lot of sample, so we only have 10 people for group 1 and 10 people for group 2. Although the two sample size are the same, 10, they are still not case 4, paired difference case, because these two groups are independent. People on a low-fat diet is independent with the people on a regular diet. They will not influence each other, so they are independent, and sample size smaller than 30, so this will be case 2. So in case 2, usually we calculate the SP square first, which is using the formula, and after that, you can use the result input in the test statistic formula. So it will be a t-score. And D0, again, it is the hypothesis value in H0 and HA, so it will be 0. And the result, after you calculate using your calculator, the test statistic is 0.618. And we will also use the two methods to make a decision. First, method 1, the rejection region. And because the sample size smaller than 30, so we need to use t-table instead to find out the critical value. First, it will be two tails problem because in HA it is not equal to. So we need to choose the row on the top, two tails alpha. Alpha is given 0.05. So we need to lock the column 0.05 on the two tails row. And degree of freedom, so this is case 2. So degree of freedom is N1 plus N2 minus 2. So it will be 18. And you need to look at row 18. And the crossing is 2.101. And remember, this is a two-tailed problem, so you need to highlight the two sides for the rejection region. So negative 2.101 and 2.101. After that, you need to see the test statistic in the rejection region or not. So the test statistic is 0.618. Actually, it is outside of the rejection region, not in the rejection region. So our decision is do not reject H0. And next, we will see the method 2 using p-value. So first, let's show the picture of the p-value. The starting point is test statistic 0.618. And remember, this is a two tails problem, so the p-value, it will be two sides. And how to find p-value, we will use t-table. And the degree of freedom is N1 plus N2 minus 2, 18. So you need to look row 18. Where is the test statistic? If you don't have exactly the same test statistic, find the two neighbors. So the test statistic is 0.618. It's between 0.000 and 0.688. So these two neighbors go up to the top row. That will be p-value range. And you need to either choose one tail range or two-tails range. And in this question, it's a two-tail problem, so you need to choose the two-tails p-value range, which is 1.00 and 0.50. And next, make a decision. So usually, we write the smaller one in front of the range and the bigger one at the end. So p-value is 0.50 to 1.00 compared to alpha. Alpha is given 0.05. So p-value range, all of them bigger than alpha. So our decision do not reject H0. Lastly, we better to interpret the result, so there is not sufficient evidence to indicate the claim in HA, which is there is not sufficient evidence to indicate that it will make a difference of obese people on a low-fat diet compared to a regular diet. Now here is another example of the case 3, large proportion problem. And we compare the year 2000 and the year 2010 to see whether there's some different for the people smoke. So we have 1,500 adults in year 2000 and sample 1,750 adults in year 2010. And we need to determine that whether there was evidence that the percentage of smokers had decreased. And also in the 2 years, 555 smokers in year 2000 and 578 smokers in the year 2010. So now let's use the group 1, the first dimension, year 2000 as 1, and the second mention, the year 2010 as 2. So there's a keyword, decreased. So which means the year 2000 actually is bigger than the year 2010. So you need to use some common sense to figure out which one is higher, which one is lower. And because this is a percentage problem, so in HA, which is the claim, P1 bigger than P2, so it decreased over this 10 years period. And one more step for H0, HA, we usually write as P1 minus P2. So HA, P1 minus P2, bigger than 0. This is a one-tail problem. And this is case 3, large independent proportion problem. So usually, I will recommend you to calculate the P1 hat first and P2 hat first and also P hat first. And after you calculate the result and input the result in the test statistic formula. So the test statistic formula, it will be a z-score. And the result is 2.38. P1 hat is the proportion for sample 1. P2 hat is the proportion for sample 2. P hat is the grand proportion, which will be the x1 plus x2 divided by n1 plus n2. So the test statistic is 2.38. Because we can use z-table, so we can also use this rejection region summary table to find out the critical value. HA is bigger than, so it will be the second column. Alpha is given 0.05, so the critical value is 1.645. So it will be on the right because HA is bigger than. And the rejection region starting point is 1.645. And test statistic is 2.38, so it is in the rejection region. So our decision is reject H0. Now let's see the p-value. So the p-value starting point, it will be the test statistic 2.38, and we need to highlight on the right because HA is bigger than, so it is on the right. And the p-value, we will use z-table according to the z-score 2.38, the table value is 0.4913. So in this picture, the shade area in yellow is p-value. It will equals to 0.5 minus the table value. So the result is 0.0087, and compared to alpha, which is 0.05, so p-value smaller than alpha, our decision is reject H0. And lastly, it's better to interpret the result, reject H0, which means there is sufficient evidence to indicate the claim in HA, which is there is sufficient evidence to indicate that the fraction of smokers decrease over this 10-year period from year 2000 to the year 2010. Here is the example 4. So now there will be like a summer camp for the overweight people, and they will develop a program, and we need to figure out the BMI was measured for 16 campers at the start of the camp and at the end of the camp. And this table is the summary statistics. And we notice in this table, it provides the starting BMI for the mean and standard deviation, and also at the end of the camp, the ending BMI, the mean and standard deviation. The last column is the difference. The difference is each difference for the 16 campers, and we calculate the mean and standard deviation. Although a lot of information is provided, but this case is case 4, the paired difference, because for each individual campers, they compare to themselves. So they compare the weight, the BMI, starting at the camp and compare to their own BMI at the end of the camp. So they compare to themselves. The same unit repeated. So it will be the case for paired difference. So let's translate the sentence into a mathematic form. So the question asked you is determine whether the mean BMI at the end of the camp is less than the mean BMI at the start on camp. And the first dimension starting is considered as 1. The second dimension ending as 2. So from our common sense, at the end of the camp is less than at the beginning. So mu1 actually bigger than mu2. So in HA is mu1 bigger than mu2. And usually we write as the difference because this is a case 4. So the difference mu-d is bigger than 0. And we only look at the column, the difference. This is the only information we needed. So actually we don't need the starting BMI column, and we also don't need this ending BMI column. So we only need the last column, the difference. And because this is case 4, so it will be a small case because we only have 16 campers. So the difference sample size is smaller than 30. And it will be a t-score. So the t-score for the test statistic, it will equals to the mean of the difference minus the hypothesis value and divided by the standard deviation of the difference and divided by the square root of the sample size of the difference. So we only need the last column. So mean is 3.3 and standard deviation is 4.5. sample size is 16. So the result is 2.933. And because it's smaller than 30, so we need to use the t-table. If the sample size of the difference is bigger than 30, you can use z-table instead. Now, let's see the critical value first. And because this is a paired difference case, so the degree of freedom, it will be m minus 1. So it will be 16 minus 1 equal to 15. So we need to only look at the row 15. And the column is alpha. So because HA is bigger, so it's a one-tail problem. And alpha is 0.01, which is given. The crossing 2.602 is the critical value, and we need to highlight the rejection region on the right because HA is bigger. And after that, we see the test statistic in the rejection region or not. The test statistic after calculating is 2.933 is in the rejection region, so our decision is reject H0. And next, let's see the p-value. So test statistic is 2.933, and we need to look at the row is degree of freedom is 15, and the p-value, actually we need to shade the area. Starting point is the test statistic on the right. Now let's look at the row 15 and find the two neighbors of 2.933. So in row 15, it will be 2.602 and 2.947 is the two neighbors between 2.933. So go up and you need to choose one-tail p-value range because in HA is bigger, so it's a one-tail problem. So p-value is from 0.005 to 0.01, and the whole range compared to alpha actually smaller than alpha. Alpha is 0.01, so our decision is reject H0. And lastly, we can interpret the result. Our decision is reject H0, so there is sufficient evidence to indicate the claim in HA, which is the mean BMI at the end of camp is less than the mean BMI at the start on camp. So that's all for this video.